Hello friend, welcome back to Kotlin tutorial. This is Golden Thumb. If you want to check the source code on our GitHub repository, you can go there. I already put the URL under the YouTube tutorial, YouTube video. Okay, so you can copy or just click right that URL like this one, GitHub, right? This is the URL, so you can go there, and let me show you how to find the code. So click this folder and app and the source. Now there are 3 folders. This one is Android test. No, we are not there. This main is our code for the app itself. So our testing code, right? Our code snippet in this tutorial for now is here. You see, this is recursion.kt, right? That's exactly this file. You see here, recursion.kt, Kotlin, yeah. So let me put it here so you can compare. Click this guy, you'll see the source code, right? In good colored syntax. Okay. Now, yeah, let's close it. So in this video, we'll create Fibonacci number solution, right? Using recursion. So let's put it here. Let's create a function to do Fibonacci. The nth Fibonacci number. Return that, right? So you know Fibonacci number, right? The rule is starting from 0 and 1, the next one will be the sum of the previous 2. So it's 1, right? Now 1 plus 1, right, equals 2. And now the next one, right, 1 plus 2 is 3. That's the pattern, right? Now 2 plus 3 is 5, blah, 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 and so on, right? Now let's try to calculate. So the zeroth one is, the first one is 0, the second one is that, right? So n means, so for example, if n is 5, it means 5, it means 0, 1, 2, 3, 4, 5. It should be 5. Oh, okay. So if n is 6, it will be 8. How can we implement that? Using recursion. There are 2 parts for any or most of the recursion function, right? Recursive functions. Base case. What if n? So we can find a pattern, right? If n is 0, if n is 0, we can return 0, right? 0 or n, right? And if n is 1, right, this one is also n, right? It's also n, 1. So we can say, to merge the 2 cases, we can use n less than 2. That's the base case. After that, we cannot, we need to do, after the first 2 numbers, we need to call itself, right? Fibo n minus 1, right? Plus Fibo n minus 2, right? So if we want to calculate this guy, we know, right? We call ourselves with a smaller scale argument. This is n minus 2. This is n minus 1. Okay, now we can try it. Why is there a... Oh, it's not called, I guess. Now let's test it. We need that, right? Test. Okay. Function print fibos. Now let's print our fibo. Let's say 5 and run it here. Yes, it's 5, this guy. Right? Next one. It should be 8, right? 8. Yes. What if we want to print a bunch of them? Let's use a for loop. 0 I in, right? A range 0 dot dot say that's 10 of them. Okay, sure. Print. Now we put the I here, like that. Run it. Okay, it's messy, so I think we can add our space in this way. This one follow. Okay, so this is the string template, right? A space. Now let's try it again. Zero, one, one, two. Yeah, cool, right? And if we want to assert, we can do something like that. Assert equals the, what is this? The index of that 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10. Okay, so equals expectation 55. Then the function called fibo 10. So let's make it fail first. For example, let's say 34. We put this one there and it will fail. Yes, fail. Oh, actually, see, expected 34. That's wrong. Actual 55. Okay, now let's put it back to make it pass. And run again. Ta-da! You see, it passed, right? Cool. So I'll update the GitHub repository with this new code. So, and put the URL, the link under the tutorial in the description of this YouTube video. Okay, thank you for watching. See you next time.